Welcome to Maths and Science by IITian channel. In this lecture, we will be talking about understanding the concept of Diophantine equation and to find out under what conditions a given equation can be a Diophantine equation. If an equation converges to a value of k, what should be the value of k so that the given equation will be a Diophantine equation? Where no numeral is given, please try to understand. It's a very challenging and very rare example on Diophantine equations. Till now we have solved the Diophantine equations. Now we are introducing a condition for a particular equation to be a Diophantine equation where no integer values are found, all are variables. Then how to find this k value? It's a very rare and challenging question in Diophantine equations, and also it involves the concepts of minimal solution, and we will introduce many concepts in this, and the value of k is found to be surprisingly an integer value, positive integer value. For this equation to be a Diophantine equation. Here a and b are not given, a and b are variables, integers. No numerical value is given, but still we will get a possible solution for k as a positive integer. Let us see how to proceed for it, and it's a very good example. See till the end, many concepts will be cleared here. Quadratic equation and also minimal solution and other concepts which we are supposed to understand and implement in number theory. Very good example. Let's go further. Very tough example. It's not an easy example. It's a challenging question and a very rare question to ask for. It is very suitable for Maths Olympiad, good maths enthusiasts, and also higher level mathematics examinations aspirants. Let us go for it. Let us go for the solution. What is the question given here? Question is find k such that what is the problem? 1 by a plus b plus a plus b by a minus b plus a minus b by a plus b is equal to k is a Diophantine equation. Except this, nothing is given. Diophantine equation means a and b should be integers, and the k value is an integer. We have to find the k value as an integer. Let us try to solve it. Solution. The sentence Diophantine equation itself gives a lot of meanings. Here what is given is 1 by a plus b plus a plus b by a minus b plus a minus b by a plus b is equal to k. For this to have meaningful integer value for k, the denominator for the second term should not be 0. Should not be 0. A minus B should not be 0. That means AB can belong to set of integers, but A cannot be equal to B. Now, in the given equation, let us simplify and write 1 by A plus B plus A plus B by A minus B plus A minus B by A plus B is equal to K can be written as if X is equal to A plus B and Y is equal to A minus B. It can be written as 1 by X plus X by Y plus Y by X is equal to K. Here A is not equal to B implies X into Y is not equal to 0. And XY also belongs to Z, set of integers. K is already an integer. We have to find the integer value of K. Now from this equation, what we get? We will take XY as LCM. Y plus X square plus Y square is equal to K. That implies X square plus Y square plus Y is equal to KXY. Do you agree? Now can we write it like this? X square minus KXY plus Y square plus Y is equal to 0. A quadratic equation in terms of X. AX square plus BX plus C. Let here it is X is equal to variable, quadratic equation in X. Let X and X1 be roots. That implies x into x1 is equal to y square plus y. From the quadratic equation properties. Sum product of the roots. Now, let us write it in terms of y. Y as the, in terms of y as the variable and quadratic equation. Can we write it? Y square this y shall we take minus y into kx minus 1 plus x square is equal to 0. That implies this particular equation represents x into x1 is equal to y into y plus 1. That implies x is equal to y or y plus 1 and remaining will be x1. Instead of taking it to y, we will do it afterwards, this one. Let us try to put x is equal to y. That implies x square minus kx into x plus x square plus x is equal to 0. That implies x square minus kx square plus x square plus x is equal to 0. That implies x square 2x square plus x is equal to kx square. That implies two x plus 1 is equal to kx. That implies k is equal to 1 plus 2 plus 1 by x. K is equal to 2 plus 1 by x. This is one value we have got. Because k is an integer, since k is equal to an integer, it implies x cannot be greater than 1. Because x is also an integer, cannot be greater than 1. That implies x should be 1. Which implies x is equal to y is equal to 1. That implies k is equal to 3. This is one answer. And second what it is? X is equal to y plus 1. x is equal to y plus 1. This implies what is the original equation? Not original equation in terms of x and y. X square minus kxy plus y square plus y. X square is y plus, how we can write? We can write as x is equal to y plus 1. Then it will be y plus 1 x square, no problem, y plus 1 whole square minus k into y plus 1 into y plus y square plus y is equal to 0. That implies y square plus 1 plus 2y minus k y square minus ky plus y square plus y is equal to 0. That implies y square plus y square minus ky square is two y square plus 2y plus y is 3y ky into y plus 2y square plus 1. What are the things we have completed? 2y square plus 2y plus y 3y plus 1, and we will send k values on the other side. Then this is equal to ky into y plus 1. Let us divide everything by y. 2y plus 3 plus 1 by y is equal to k into y plus 1. Here k should be an integer. For k should be an integer, y should be an integer. And if y is greater than, for 1 by y to be integer, y cannot be greater than 1, which implies y is equal to 1. Which implies x is equal to 2. And from here k is equal to k into 2 is equal to 2 into 1 plus 3 plus 1 implies 2k is equal to 6. That implies k is equal to 3. For either values, for this equation to be true, we have k is equal to 3 as the solution. Let us verify this solution. Verify. X is equal to 1, y is equal to 1 will yield what we have assumed previously for x and y. x is equal to a plus b. A plus b is equal to 1. A minus b is equal to 1. That implies A is equal to 1 and b is equal to 0. Here AB belongs to this set of integers. That implies the given equation 1 by a plus b plus a plus b by a minus b plus a minus b by a plus b is equal to k has a value of k as 3 with a is equal to 1 and b is equal to 0 to be Diophantine. This is the answer. If you have any other value of k, please try to solve this example. It's a very rare and challenging example. And we got the value of a and b as a is equal to 0 and a is equal to 1 and b is equal to 0 and k is equal to 3. If you have any other value, from k is equal to 3 we got a and b. Don't assume a and b initially. Try to find out k, then go for the values of a and b. From the values of k. This is a very rare and challenging example in Diophantine equations. Here we have not told that a and b values we have not given, k value is also not given, and we only put the condition that a, b and k are such that the whole system forms a Diophantine equation. Find the value of k. This is reverse of the questions being asked. So mathematics is such a good science that we can go either way, we can prove the theorem. In this particular example, if I have given k is equal to 3 and ask you to find out a and b values for the above equation to be Diophantine, you will be able to find. That's a simple one. Whereas, if we have to find out k for which left hand side and the whole system is a Diophantine equation, that is a tricky question and a challenging question. And if you feel there is a value addition to you because of this lecture to you, please share my video and subscribe to my channel Maths and Science by IITian, and also hype my video and become my channel member. Thank you. Best of luck to everybody. Thank you for listening to me and thank you for viewing my lecture. Best of luck to everybody. Thank you.